Hello everyone. Today we are going to talk about the rest of the thing from stereochemistry. We have done most of the things. So now we are going to talk about conformations. So the very first, we are going to discuss the ethane molecule. So this is the ethane molecule. We can assume any carbon as a front carbon and any one as a rear. Suppose this is the front, this one is a rear. So front carbon is denoted through dot and rear one is a circle one. So suppose this is my front carbon and you can see the front have 3 hydrogens. Suppose this one, another one. I am going to draw here with the red. And you can see here, this one also have the 3 hydrogens. Suppose this one, H, H, H. Now we are going to rotate this. So I am going to rotate the 60-degree angle with respect to any one of them, either front or rear, it's your choice. Suppose we are going to fix the front carbon, means the green one. And now we are going to rotate the 60-degree angle with respect to the rear carbon. So if you rotate this, the red one, then it would be H here. This H would be here and this one here. And if you are going to rotate again 60-degree angle with respect to the rear carbon, then you will get the first compound. So ethane have only two conformation, the 1 and 2. And whenever the angle is 0 degree, you can see this theta is here 0 degree. So this is called eclipsed form, eclipsed. And here the angle is 60 degree between two bonds. This is called dihedral angle. And this one is known as staggered. And if you're talking about this stability, so staggered form is more stable than eclipsed. Because in eclipsed, the bonds are very close, so they have, repulsion. That's why it has highest energy. But staggered, they are a bit far from each other, so less repulsion, it means more stability. So we can say stability and energy are inverse of each other. Okay, so higher the energy, lower the stability. Now the next one we are going to talk about the butane molecule. CH3, CH2, CH2, CH3. Suppose this one is my front, this one is my rear. Front and rear always be adjacent to each other. So look at the front carbon. One bond is methyl and two are hydrogens. Now look at the rear carbon. One is methyl and two bonds hydrogen. Now we are going to rotate 60-degree angle with respect to the rear carbon by keeping fixed the front one. So CH3, H, H. And if we rotate the 60-degree angle with respect to rear, it would be here methyl, here H, here H. Now I am going to rotate again 60-degree angle with clockwise. So again, I am going to fix the front carbon. So CH3, H, H, and this is the rear one. So methyl, H, H. So again, we are going to rotate 60-degree angle. And again, I am trying to fix the front carbon. CH3, H, H. Now look at this methyl. If you rotate 60 degree, it would be here. Hydrogen here, hydrogen here. Again, the same thing, 60-degree angle. CH3, H, H. Now this would be CH3. Here H, here H. And again, I am going to rotate 60-degree angle. CS3, H, CS3, H. And if you are going to rotate again, then it will repeat the compound one. So 1, 2, 3, 4, 5th, and 6th. Let me write down the name of them. Whenever angle is 0, it would be called as eclipse. So this is eclipsed. And whenever the angle is 60 degree, called is staggered. This is staggered. This is eclipsed. This one is staggered. This one is eclipsed. And this one is staggered. Now, whenever same group lie with the same at 0 degree angle, you can see methyl with methyl, hydrogen, HH. So this is called fully eclipsed. And whenever the groups are not same at 0 degree angle like this is called partial eclipsed. Partial eclipsed. And in staggered, whenever the groups are same at 180 degree angle like this, methyl. So this is called anti-staggered. And again, this is partial eclipsed. Okay. So if you are going to compare the stability order, so we have very clear information is staggered always be more than eclipsed. But in staggered, it is of two type, anti and normal one. So if you are going to talk about stability order, anti staggered have the highest, then staggered, then partial eclipsed, and then fully eclipsed. Okay. So fully eclipsed is the least stable because the same group lie with the same at 0 degree angle. So they have highest repulsion. So this is the Newmann projection of normal butane. Okay. Conformations basically we can say. Now the next thing we are going to talk about cis-trans in chair form. First we are going to talk about ring, cis-trans in ring. So whenever the groups wedge like this, wedge or dash, this is called cis. And whenever the groups wedge and dash, this is known as trans. For example, look at this. So this is trans. And whenever groups like this is called cis or this. Sorry, this is trans. Okay, let me write down this as well. This is trans. This is cis. Okay. Now we are going to talk about chair form of cyclohexane. So chair form means we can draw the chair like this. This is the chair form. Here we have two positions. One is axial, another one is equatorial. This is A, this is E. So what is axial and what is equatorial bonds? So look at the positioning. Look at the corners. And we can start the numbering from any position. It does not matter like which position would be my one. So any one, 1, 2, 3, 4, 5, 6. It could be anyone as one. Now look at the corners 1, 2, 3, 4, 5, and 6. Now look at the corner number 1. It is approaching upward, you can see. Up. So if you are going to keep a bond in the direction of corner like this. Now look at the number 2, it is approaching down. So corner is going down. So keep a bond down. Number 3, again corner is up, bond up. 4 down, 5 up, 6 down. So the bond which is in direction of corner, that is called axial bond. So they are all axial. What is equatorial here? So 1, 2, 4 and 5. Equatorial is super easy. Horizontal bonds like this. These are equatorials. But for 6 and 3, the NT to the axial bond are equatorial, like here and here. Equatorial, equatorial. Make sense? For example, what is the position of these groups and what is the direction of these groups? So I said that if you are going to apply IUPAC naming system, then we know that we should start numbering from that side where the branch get the lowest. So these two are the branches, and it can be anyone as one, but whenever the groups are there, so you have to decide with the alphabetical order. So E comes first, so it should be, if you are going to talk about the cyclohexane numbering, so this is my 1, 2, 3, this is 4. So 3, 4, and this is 5, this is 6. So 1, 2, 3, 4, 1, 2, 3, 4. So this is 1, 4 position. And look at this methyl. This is not in the direction of corner. This is anti to the direction of corner. So this is equatorial. And the ethyl, this is also anti to the corner. So this is also equatorial. Clear? So I am going to talk about the stability of, the chair form of groups. So we can say here equatorial bonds are more stable than axial. More stable than axial. Second, more equatorial, more stability. More equatorial, more stability. Third, bulky group at equatorial are more stable. Bulky group at equatorial are more stable. So bulky means it's not a fixed value bulky. Bulky is a commutative value. Suppose we have two groups like methyl and ethyl, then ethyl is a bulky. If we have suppose ethyl and propyl, then propyl is a bulky. Similarly, propyl and butyl would be bulky. So bulky is a like commutative value. It's not like a fixed one. For example, suppose we have these two compound and we have to decide which one is more stable. So first define the position. So this is equatorial, this is equatorial. This is axial, this is equatorial. So I said that more equatorial, more stability. So this one is more stable. In this case, we have equal number of bonds, like this is equatorial, this is axial. Here this is axial, this is equatorial. So whenever we have equal number of bonds, then we can decide by the bulky group at equatorial. So this is tertiary butyl, which is bulky here, and it is at axial here, and here this one is equatorial. So this one is again more stable. Okay. Now the next is, suppose we have to convert this form in the chair form. Chair form. This is 1, 2 position. So first we will draw the chair form like this. So this is wedge. Wedge means up. This is dash. Dash is like down. So one methyl is up. Methyl is up. 2 methyl down. Methyl down. Now there is a called ring flipping. So I am going to flip the ring and they are equilibrium of each other. So what is ring flipping? Ring flipping means it should be down and it should be up like this. In this way. So now look at the positions. Here this is my one. So this one would be here and this is my axial. So it becomes equatorial. And this one is again axial. Number 2 bond, this is number 2. So it should be, this is both are axial. So both would be equatorial here. You can say equatorial, equatorial. Now this is compound 1, this is compound 2. And my question is, they are in equilibrium. So which form would exist more in amount? So more stable form. Here both the equatorial, here both axial. So this form would be more in amount because more stable form. So we can say more stable form. So this is the most stable form of this, okay? Suppose we have this one. Suppose this is methyl, this is ethyl. So we can draw the chair form first. Methyl, suppose my 1 and this is 3. You can start any one as 1. So with this is up. So this is up. This is down, number 3 position. Okay, number 3 this is. And number 3 is down means you can keep this one as number 3 or this one as number 3 from both the side. Suppose this one I am talking about, this one. So down means here ET. And if we are going to flip the ring, axial, equatorial. So this axial would be equatorial. And 1, 2, 3. 1, 2, 3. This is 3. And this equatorial would be axial. So this is equatorial methyl, this is axial ethyl, this is axial methyl, this is equatorial methyl. So now my question is, which form would be more stable between 1 and 2? So look at the number of axial and equatorial bonds. So they have equal number of axial and equatorial bonds. And we know that if you are going to compare the bulky group between ethyl and methyl, ethyl is bulky. So ethyl should be at equatorial. So this form would be more stable form because ethyl at equatorial. Okay. So this is the conversion of ring form in the chair form. Now we are going to talk about cis trans in chair. Whenever positions 1, 2 and 1, 4 position, 1, 2 and 1, 4, axial, axial, equatorial, equatorial, that would be trans. And axial, equatorial would be cis. Look at the example. This is 1, 2, this is 1, 2, this is 1, 4. Axial, equatorial, 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 axial, axial. So I said that same means trans. So axial, equatorial, this is anti, so this is cis. This is equatorial, equatorial, so trans. And this is axial, axial, again trans. So this is for 1, 2 and 1, 4 position. Now next is 1, 3 position, just opposite. It means axial, equatorial would be cis. Axial, axial, equatorial, equatorial would be trans. Oh, wait. I think I made mistake. Axial equatorial would be trans. Axial equatorial would be cis. Just opposite. Like this. This is axial, this is equatorial. The position is 1, 3. And this one is called as trans. Okay. So this is about cis trans in the chair form. Now next is, sometimes we have this kind of structure. Suppose this is wedge bromine. And here we have, suppose again, wedge bromine. And we are looking from this angle. And we have to draw its Newmann projection, Newmann. So what should be the drawing? Let me explain. So here wedge is my bromine, so dash should be H. And here wedge is my bromine, so dash should be H. So if you are looking from this angle, it means this should be my front carbon. And this should be my rear carbon. And Newmann, you know that the groups should be like this. This is the Newmann. Where the dot is my front. Let me draw this through green. Dot would be my front. And the red one would be the rear one. So this would be my front. And this would be my rear. So whenever the wedge bond is there, that means right. And whenever the dash, it would be left. So look at the front carbon. This methyl is in the plane bond and is in the downside, so it should be down. Okay. Let me draw like this, basically. Suppose I am talking about this front carbon, so it's like just like this methyl. And bromine on the wedge. So wedge means a right side. So it should be bromine. And hydrogen on the dash, which means left. So hydrogen on the left. Now look at the rear carbon. This is the rear one. This plane bond methyl is straight up. So keep up. And wedge bromine again right. Dash hydrogen left. Now I am going to fix this over here. So it should be like this, methyl H Br. Okay, so this is the conversion of this to this. I hope it makes sense. Okay, so this is the wedge dash to the Newmann projection. Now the next is, suppose we have this one. And we are looking from this angle. So if you are looking from this angle, it means just opposite. Opposite means, let me tell you. So this is my front, this is my rear. So look at the front carbon. This is the dot one. Methyl is down, so keep methyl down. We know that wedge is right, but from this angle, the wedge would be left. So left would be my H and the dash would be right. Now look at the rear one, circle one. This bond is like this, straight up. And again, wedge is left and hydrogen would be right. So draw this. So this is the Newmann projection, okay? I hope it makes sense. Now the next is, suppose, how to draw the Fischer projection from the Newmann or from, the Fischer to Newmann. Suppose we have this one. how we can draw the Newman one? So look at here, Newman and Fischer. Fischer is basically eclipsed form of Newman. This is my Fischer projection. So this is eclipsed form of Newman. Okay. So how we can draw the eclipse form? So look at this front carbon. Methyl is up, methyl is up. H in the right, keep H in the right. OH in the left, keep OH in the left. Now look at the rear carbon. This is the rear carbon. Now you have two things. You can draw first staggered, you can draw first eclipse form, and then you can draw its rotating the molecule in the staggered form. So we know that Fischer is the eclipsed of Newman. So this is the eclipse form. So we have to draw eclipsed here as well. Okay. So how we can draw this? Look at. First, let me tell you the direct approach. What is the direct one? This methyl is down, so keep methyl down. Now look at here. We will exchange the group. Means if we are going to keep hydrogen here and Cl here, then it's a direct conversion of this to this. So it should be H over here and Cl over here. So this is the correct conversion. Okay. So this is the trick basically. Keep the anyone as same, like this is the front one. So keep this one as the same. And now for the bottom carbon, just exchange with the horizontal lines. So it can give you direct conversion. I hope it makes sense. And if you want to draw, it's supposed to be eclipse form, then you have to rotate the molecule. For example, CS3, H, OH. Now this is my CS3. Okay. This Cl is in the side of OH. So Cl. And this hydrogen in the side, hydrogen. Now you have to rotate 180-degree angle to make it staggered. So look at the rotation. Suppose this is the green line. I am going to keep front carbon fix, means the red one fix. Methyl, OH, H. And now I am going to rotate the rear carbon with respect to 180-degree angle. So if you rotate 180-degree angle, it means this methyl would be here, this. So methyl. And this hydrogen, just 180-degree angle. So it should be over here. And chlorine should be here, chlorine. You can rotate one by one basically. Means first you can keep methyl over here. Then methyl rotate another 60-degree angle to this compound eclipse, and then again staggered. So we have done this in the Newman projection of the cyclohexane. Okay. If you want to rotate, you can do one by one, but 180-degree angle direct rotation would be good. So this methyl is here. So if you rotate 180-degree angle, it should be here. This methyl should be here. And if you rotate this chlorine at 180-degree angle, so it should be here and hydrogen should be here. Okay. So you can see the same thing. It's better to exchange it directly here than to rotate. Clear? I'll give you another one. Suppose this one. Okay, now we have to rotate the molecule. Oh, we have to draw the Newman projection. So suppose this is my front. So methyl, bromine, NH2. This is the front one. Now the rear carbon, simple, methyl. Now switch them, OH here, H here. So OH and H. Okay. So this is the Newman projection. So in this video, we have done the chair form of cyclohexane. We have done the conformations of ethane and normal butane, and we covered the conversions like the Fischer to Newman, okay, and wedge dash to Newman as well. So I think we have covered most of the things. If anything left, I will again record and upload. So I think we are almost done with the stereochemistry. So in the group session, we will talk about the questions. So thank you so much, everyone.